Okay, this video is about stage 2 metabolism, specifically the specific pathway for degradation of amino acids. So, proteins are broken down to form amino acids, and amino acids can sometimes form acetyl-CoA. Amino acids are not usually metabolized, though. Normally, amino acids are used to build other proteins. However, it is possible for amino acids to be oxidized to make acetyl-CoA when necessary. So, normally if we took a protein, right, and in stage 1, or in digestion, we would have stage 1, digestion would be hydrolysis of the amino acid, or excuse me, of the protein into individual amino acids. The protein would be broken up into one amino acid, and another amino acid, and another amino acid, AA for amino acid, and so on. And again, normally they're just put back together to build proteins that we need. However, they can undergo catabolism, right? They can be, broken down for energy, essentially. So what might that look like? Well, let's just look at an example. What if we looked at alanine? Okay, so that would have NH3 plus, and then it would be bonded to a carbon that would have a methyl group on it and a C double bonded to an O, and then an O minus. So NH3 plus, CH with a CH3, and then CO minus, or C double bond O, and then an O minus. So what might happen is that NH3 bond might be cleaved, and that NH3 broken off and given off as NH4 plus or as ammonia. And that would go through this urea cycle, and it would end up as urea excreted, through first your kidneys and bladder and out through your urine. Okay, well, what's remaining then? Well, a 3-carbon skeleton, a CH3, a CH2, a COO minus, or a pyruvate that can be cleaved further for 2 of those for a 2-carbon acetyl-CoA group, and then can go into the citric acid cycle. So suffice it to say that these can be, catabolized or broken up and used if necessary. Amino acids aren't stored in the body. So generally speaking, they're built up in different ways to make new proteins, but they can be catabolized for energy if it's really needed.